All right, practice exercise number 75. Practice exercise number 75. We got a little bit of algebra review in our last lesson, and this, like many of the other concepts we've done in our recent practice exercises, more algebra review, word problems in which you'll need to set up an equation and solve for the answer or answers. So some good review for you. You may use your calculators. Exercise 75, and to go ahead and get started on that. Reckon, go and have just a pen, clear everything else away. let's go ahead and take a look at these together. And obviously you noticed a theme here, right? Consecutive numbers. And how do we represent, Chris, any number? X. And the next consecutive number after x would be x plus 1. So on the very first problem, for instance, when it says the sum of two consecutive numbers is 27, what would our equation be?
2x plus 1 equals 27.
Right, the sum of them would equal 27. When you solved, you got x was equal to 13, which means your two numbers were 13 and 14. Great job. On the next one, Chris, you had 5 consecutive numbers. So how would you represent 5 consecutive numbers?
X plus 1, x plus 2.
Well, you could do that, I suppose. I would start with x and then do x plus 1, but...
Okay, x plus 1, x plus 2, x plus 3, x plus 4.
Now, technically, it wouldn't be wrong to start with x plus 1. Did you do that on your work? You started with x plus 1, x plus 2, x plus 3, x plus 4,
I
x plus 5?
solved these without using an equation.
Oh, okay, we didn't need the equation, technically. We'll roll with it anyway, though. And the sum of them was supposed to equal...
5x plus 10.
There we go, think bowling, right? 1 pin, 2 pin, 3 pin, 4 pin, 10 pins. All right, equals...
Negative 5.
Negative 5. So here we'd have to solve and end up getting x is equal to... Negative 3. So your numbers were...
Negative 3, negative 2, negative 1, 0, 1.
And there we go, and the sum is negative 5. On the next one, we had 3 consecutive even numbers. Now, how would we represent any even number?
X.
Well, x could be even or odd, but to guarantee even...
X plus 2.
Not necessarily. Class, anyone remember from past years? 2x is guaranteed to be an even number. What would be the next even number after 2x, anyone?
2x plus 1.
2x plus 2, right? Because even numbers would be spread out by 2. But we've got 3 consecutive even numbers. What's the next even number?
2x plus 4.
2x plus 4. So these would have been our 3 consecutive even numbers. And it says the sum of those numbers is 48. So the equation here, Chris, would be
6x plus 6 equals 48.
And what do we end up getting for x?
14.
Well, we end up getting 7 for x when we solve. But our first number, our smallest number is 2x. So our first number is 14. And that would have been our answer for the third one. Now, I didn't ask about odd numbers anywhere on here, but how would I represent any odd number, class? 2x plus 1. Take an even, add 1 to it, you're guaranteed odd. What would be the next consecutive odd number, anyone? 2x plus 3, and then after that, 2x plus 5, and so on and so forth. Again, there were no problems dealing with odd numbers on here. And then it says here, when the smaller of 2 consecutive numbers is added to the numerator, and the larger is added to the denominator in the fraction 2/3, the result is 3/4. Find the numbers. How would we set up this equation, Chris?
I did x over x plus 1.
Well, this would be a small number, and this a larger number, but the smaller number was supposed to be added to the
denominator.
Okay. When the smaller of 2 consecutive numbers is added to the numerator, which the numerator of the fraction started out as 2. So we start with a 2, and to the 2 in the 2/3, we add the smaller of consecutive numbers. To the 3, we add the larger of 2 consecutive numbers. And it says when the smaller is added to the numerator, when the larger is added to the denominator of 2/3, the resulting fraction is 3/4. And so this should have been our equation here. Now we can simplify a little, add the 3 and 1 to get 4. So it's really 2 plus x over x plus 4 equals 3/4. Well, we just recently talked about this. What is this thing, class? Proportion. Good, Kendall. And to solve proportions, class, we will cross multiply. So back to Chris, when I cross multiply the extremes, I would get
4 plus 4x. Or no, 8 plus 4x, sorry.
And when I cross multiply the means,
3x plus 12.
and we end up getting x is equal to...
Well, I didn't have the right answer.
Okay, we should have had anyone x equals 4. So therefore my smaller number is 4, and the larger number would be 5. So when I add 4 to the numerator, 5 to the denominator, it turns 2/3 into 3/4. So Chris, you did not get 4 and 5 for the last one. All right, we got the first few correct. Again, would have liked to have the equations to go with it. Do the equations make sense?
Yeah.
All right. Jamie, you were second. Did you get them all correct?
I think so.
You think so?
What was the answer for the third one?
For the third one, 14 was the answer.
Okay.
Because what is the smallest number? So the numbers were 14, 16, and 18, but it was only interested in the 14.
I put the 3 there.
But you did have 14 as your smallest. Okay. All right, good job. Ethan, you were third. Did you get them all correct by any chance? All right. Okay, does it make sense now? All right. Others of you didn't necessarily finish. How many said, of all the ones I did, though, I was doing them all right, I just didn't have time to finish? Okay, several of you. Good. Questions on any of these? Questions on any of these? All right. Go ahead and turn those in if you would pass those forward. Bracken, you finished back there? All right, let me go and collect that from you as well. And to go and take out your homework from last time, homework from Friday. And before we go over the homework, books open, by the way, to page 191. So homework out, books open at page 191. Let's go and review some terms. And I already reviewed a few of them with you a moment ago. But we began talking about a comparison of two values. And what do we call this comparison of two values, Kendall? A ratio. And there are 3 ways to write a ratio. For instance, if we wanted to take the ratio of guys to girls, there's 3 guys in the class, 4 girls in the class. Genesis, how could we write a ratio of 3 to 4?
3, 2, 4.
Good.
3, 4, comma 4.
How about a comma with a different punctuation mark, class? Colon. Colon. Still starts with a C. So 3 colon 4, or the best way. 3 over 4. And this is the way I told you. I really want your ratios to be written in this class. Not that the others are wrong. This is just best. Now, this first number in the ratio, the 3, Ethan, we call the... help him, Chris?
The antecedent.
Antecedent. And then the 4, the second number, back to Ethan. Consequent. Okay, he remembers it now. And if I were to take this ratio of 3 to 4, and I were to say, well, that's equal to the ratio of 15 to 20, correct? They're equal ratios to each other. I can multiply both the top and bottom by 5 to get that, or divide the 5 to get this again. So they're equal ratios. An equality of 2 ratios, as Kendall said a moment ago, class, is called a proportion. And in the proportion, which could be written 3 is to 4 as 15 is to 20, or 3 is to 4 as 15 is 20, the first and the fourth terms are referred to, Jamie, as the... The first and fourth terms we call the... Quentin, helper?
No.
Other one? Extremes. Because they're on the outer edges, if you will. So the extremes would be the first and the fourth. The smallest and the biggest, in this case, they happen to be. And then the middle 2 terms here are referred to at class as the means. And so within the proportion, I said that the 20 specifically, now it's one of the extremes, obviously, but because there are 1, 2, 3, 4 distinct terms, Jamie, this fourth term is referred to as the fourth proportional. And frequently that'll be one of the things we'll solve for, is that fourth term. However, I did say it's possible, let me change this up just a little bit here. Let's say 1 is to 5 as 5 is to 25. It is possible that the second and third terms could be equal. That is, the means could be equal. And if that's the case, Audrey, each of these terms, or this value of 5, is referred to as the mean proportional. And if we have a mean proportional, we don't have 4 distinct values, we have 3. So now the fourth term is not the fourth proportional, but rather, class, is called the third proportional. You cannot have a third proportional without also having a mean proportional. So if you have a mean proportional, what does it mean to have a mean proportional, Ethan?
The 2 middle numbers. The middle.
Are the...
Mean.
Yeah, but what does it mean to have a mean proportional? Because I have means here, but I don't have a mean proportional. To have a mean proportional,
They have to be equal.
right, the means have to be equal. The second and third terms are equal to each other. Then, class, this fourth term again is called the third proportional. But if there's 4 distinct values, it's called the fourth proportional. You practiced with some of this in your homework over the weekend. Page 191, you've got your textbooks open there. You did number 4, C and E, number 7, B, D, and F, number 9, A, C, E, and G, and number 11, B and E. So quite a bit there. Go ahead and have that out if you would, please, so I can check as I come around. Excellent, thank you, sir. Good, very neat work. Thank you, Genesis. Also very neat there, Jamie. Thank you. Good, Kendall. Question mark. Oh, that says you didn't write any proportions.
No, I went back and I wrote the answer. I went back and I wrote the
Make sure we show the proportions, by the way. That's going to be important to show the proportion as well as the answer. Let's take a look at these. Number 4C, we were given the proportion 6 is to 5 minus x as 7 is to 3. Note the way that's red. And 6 is to 5 minus x as 7 is to 3. And of course, to solve a proportion, we would simply cross multiply. Genesis, let's start with the means here, and we get
5 minus 7x.
There we go, just distribute the 7. And of course, the extremes come to a single value. 18. To solve, of course, we would need to get the x by itself. A couple ways we could do that. And if we're going to do that, let's also ditch the 7x as a positive. So we subtract the 18 to get
17.
There we go. And over here, when we move it over, it becomes a and we just divide both sides by 7. Now, in Algebra 1 and Algebra 2, we would have said, let's just leave 17 sevenths because of what we're working with. We're going to be working with feet and inches and things like that. I told you, I want you to get in the habit of writing it as a mixed number. What would that improper fraction be if we made it a mixed number, Genesis? Three sevenths, 2 and 3 sevenths. Now, the nice way to do this is if you're a little weak in fractions, and I know you weren't here, last year was your first year, just type 17 fraction 7 on your calculator, and when you hit enter, it'll change it to 2 and 3 sevenths for you. So again, you don't even reducing ratios, right? Even if you got a fraction, you wanted to reduce it, type it in your fraction. As soon as you hit equals, it'll reduce everything for you as well, I believe. Right? So, take advantage of that, particularly if fractions are not your strong suit. That said, if you can't do it in your head, that's nice too. Let's take a look at how many you have, by the way. I have this answer, 2 and 3 sevenths, or maybe left 17 sevenths. Again, gotta show that proportion. Looking at letter E, how would I set this up in fractional format? Kendall?
N is to N as S minus X is to Y.
There we go. And we're solving for the X. That's what it says in the instructions. This is what we call a literal proportion. Remember that term, literal equation, literal proportion, because it's all letters. But we're solving specifically for the x. But to start out, we do what we always do, class.
Multiply means by the extremes.
Multiply the means to each other, multiply the extremes, cross multiply, right? And when we do, Kendall, what do we get? On one side,
MR.
Mr. And on the other side? Or we'll keep it alphabetical here. And then we want to get the x by itself. So what might we do?
Divide with N.
We could. That would leave us with mr over n equals s negative x. And then what could we do? We could by making it a negative. So we have mr over n minus s is equal to negative x. And then I really didn't want a negative x. So as a last step, and there's one way to write the answer. Anyone do it slightly differently when you got to this step? All right, Jamie, what did you do? Instead of dividing away the n, which is not wrong, by the way, what did you do?
I put the index over on the other side to make it positive.
And I assume also
the MR
over as a
negative.
And then you went ahead and divided away the n. And these are exactly the same answer. So they're both correct. I made one of those for this one here. Right? Questions on that? All right, let's take a look at number 7, letter B. The instructions for number 7 were to find the fourth proportional. So we needed to start by writing out the proportion. 7b, they gave you the first three terms, 4, 3, and 9. How do I write the proportion if x is the fourth proportional? Audrey?
4 is 3x, 9 is x.
And when you cross multiplied and solved, what did you get x to equal?
6 and 3/4.
Good. 4x equals 27, so x is 27 fourths, but we prefer the answer 6 and 3/4 on 7b. How many had that answer? All right, very similar on letter D. How would I set up the proportion, Quentin?
9 is to 3, 4 is 6.
And when you cross multiply this time, what did you get?
9x equals 12.
And ended up with an answer of x is equal to,
I actually would have get that.
well, let's go ahead and divide away the,
9.
to get
3/4.
12 ninths, which becomes 4 thirds, which equals
1 and 1/3.
1 1/3. Should have been our answer for letter D. How many had 1 1/3 for D? All right, what about letter F? How would I set that up? Chris?
9 is to 4 is 3 is to 8.
All right, and we cross multiply to get?
9x equals 12.
And we're like, hey, that sounds like we just did a minute ago. So x, of course, once again, is just going to equal
1 1/3.
1 and 1/3. How many had that again for letter F? And notice different answer depending on the order of the terms, correct? So the order makes a difference. You can't just be given any three numbers, finding that fourth proportion that will not always be the same, as we discussed. Turning the page, number 9. You did A, C, E, and G. This time you were finding the mean proportional. And again, what does it mean to have a mean proportional, class?
Means you're equal.
The means are equal. So if you're finding the mean proportional, then that means the mean proportional has to be the x, which means both second and third terms are x. How do we set up the proportion on letter A? Genesis.
5 is to x, because x is to 2.
All right. And when you cross multiplied, it actually gave you a quadratic. X times x equals 100. So you've got to then take the square root of both sides, don't you? To get rid of that square, giving you x is equal to, what is the square root of 100? What times itself gives 100? Not half of 100. What times itself? Helper class? 10. And you can do this on your calculator as well, right? Because you've got a square root button there. I think it's above the, is it above the 5, above the 8? Above the 9. Two keys above the 9. You see the square root of x key on your calculator there, Genesis? So if you were to type in 100 and then hit that button, it'll give you that square root 10. But technically, class, positive negative 10. Now, if we were dealing with lengths, you wouldn't need the positive negative, because how do you do negative 10 inches, right? I mean, okay, but I guess shrinking 10 inches would be negative 10 inches. But anyway, get back down under 3 feet, right? But anyway, but since there were no units, it's technically positive negative 10. Should have been our answer here for letter A. How many had that? How many had the 10 but forgot the positive negative? All right, questions? All right, looking at letter C. How would I set up this? Solving for the mean proportional. Chris?
20 over x, 5 over x. 20 is x is to 5 is, oh no, x is to 5.
There we go, as x is to 5. There we go, keep the x in both spots. Once again, we cross multiply, we're going to get...
I forget the name of it, whatever. You get x squared equals 100.
Yeah, x squared equals 100, so it's going to be another positive negative 10. How many have that again for letter C? Probably if you missed A, you also missed C. How do we set up letter E, Ethan?
18 is to x is 8, x is to 8.
For letter E?
Number 8.
8 is to...
X has 18, or x is 8.
There we go. 8 is to x, it's x is to 8. Again, keeping the number, it's in the correct order. However, turns out it doesn't make a difference, does it, right? When we cross multiply, we get...
X squared equals 144.
And of course, that means x is going to equal...
Positive negative 12.
Good, you remember the positive negative. 12, there, our answer there. Of course, letter G is what he said a moment ago. 18 is to x is to 8, but it's still going to be x squared equals 144, so it's still going to be positive negative 12. How many got E and G both correct at positive negative 12? How many of the 12 forgot the positive negative? Questions at all on that? So notice mean proportional, does it matter what order the two values are in? It really doesn't. It's going to be the same either way because you're just multiplying the values. Number 11, you were finding the third proportional. And on letter B, I'm finding the third proportional class, which means I must also have a mean proportional. How would I set that up, Jamie?
12 is to 8 as is to x.
Right, 12 is to 8 are the only numbers they give you. But if there's a third proportional, it's got to be a mean proportional. So if this is 8, that's got to be 8. And of course, this x falls in your fourth spot. We cross multiply, Jamie, to get
12x equals 64.
And unfortunately, it doesn't work out evenly, but you end up getting
5 and 1/3.
5 and 1/3 when you put 64 fraction 12. Now, if you do 64 divided by 12, it can be 5.3 repeating. I hate decimals, particularly repeating decimals. I much prefer 5 and 1/3. So use the fraction bar instead of the division key. Okay, so 64 fraction 12 instead of 64 divided by 12. Letter E, how would I set that up? Quentin.
8 is 12 is 6.
And when we cross multiply this time, we get
8x equals 144.
so this time we end up getting x is equal to
18.
so notice the same two numbers, but because they came in a different order, again, it changed what your third proportional was. So really the only time the order doesn't matter, class, is when you're finding a mean proportional. How many got 18 for letter E? Questions at all on finding third proportionals, fourth proportionals, mean proportionals, or just solving proportions in general? Any questions at all on the homework? All right. Notebooks out. Turn to the properties and transformations section. We've been waiting on this section all year. I know some of you, as you turned in the notebook, it just frustrates you to no end to have a grade form that includes 0 points possible on properties, transformations. Like, when are we ever going to put something in that section? Today is the big day you've been waiting for. How many are like, you are such a nerd? How many are like, that's me he's talking about? Okay, a couple of you. All right, anyway, properties, transformations. This section is for proportions. There are several properties of proportions we want to talk through, and there are several transformations of proportions that we're going to talk through. Today we're going to talk through properties, tomorrow will be transformations. So property 1, we'll abbreviate prop 1, because we're too lazy to write the whole word. Property 1 says this: in any proportion, the product of the means equals the product of the extremes. In any proportion, the product of the means equals the product of the extremes. This may have been a statement you had to memorize in your younger years. How many are like, I think I already know that when we've talked through the proper product of the means equals the product of the extremes. It's called the fundamental property of proportions, if you'll write that down. This is called the fundamental property of proportions. The fundamental property of proportions, that in any proportion, the product of the means equals the product of the extremes. By the way, this is why we cross multiply, is because the product of the means equals the product of the extremes. For instance, if we were to take the proportion A is to B as C is to D, and I wanted to prove that the product of the means, BC, equals the product of the extremes, AD. How would I prove that that must be true? Well, you'll recall in algebra, I told you, anytime you have fractions in an equation, I told you multiply everything by the LCD, right? Which in this case, the least common denominator is BD. Well, the reason this works is because if you have equal quantities and you multiply them by equal quantities, the products must be equal, right? Okay, that's your multiplication axiom. Well, here the B's would cancel because you're dividing equals by equals. They cancel, leaving you with AD. And then here the D's cancel to give you BC. Oh, you mean BC equals 80. Yeah, I mean, it's a really easy proof. It's basically a 2-step proof in a sense, or 3-step proof, I guess. But yeah, just multiplying both sides by the same thing. That's why the product of means equals the product of the extremes. Property 1, corollary 1. Property 1, corollary 1. If 3 terms of one proportion, if 3 terms of one proportion equal 3 terms, equal the 3 corresponding terms of another proportion, if 3 terms of one proportion equal the 3 corresponding terms of another proportion, if 3 terms of one proportion equal the 3 corresponding terms of another proportion, then the remaining terms must be equal. Then the remaining terms must be equal. If 3 terms of one proportion equal the 3 corresponding terms of another proportion, then the fourth terms must be equal. So let's say, for instance, we've got a proportion 2 is to 3 as 5 is to x, and 2 is to 3 as 5 is to y. You know what's got to be true about x and y? They got to be equal. Why? Well, because you already know the product of the means equals the product of the extremes, right? So whichever term the x and y happened to be, and I picked the fourth spot, but it could have been anywhere, right? I could have put the x here, for instance, and the 2 here, and the y here, and the 2 here. Notice I still have 3 terms equal respectively to their 3 corresponding terms. Well, when you cross multiply, since both 2x and 2y are equal to 15, quantities equal to the same quantity are going to be equal to each other. 2x and 2y have to be equal. And because they both have the same coefficients, divide both sides by 2, halves of equals are equal, x and y have to be equal, right? Of course, if 3 terms equal, now, that refers to the corresponding terms, right? I can't say 3 is to x as 2 is to 5, and 5 is to y as 3 is to 2, and now are x and y equal? Well, these 3 terms aren't in the same spots, right? But if the letters all match, even if they were literal, for instance, A is to Z as Q is to M, and A is to Z as G is to M, if those two are both true proportions, what must be true? Anyone?
G equals Q.
G and Q have to be equal to each other because the other 3 terms are all exactly the same in the same spots. Does that make sense? Okay, that's property 1, corollary 1. Property 2. This is a fun one. Property 2. If the product of 2 quantities equals the product of 2 other quantities, if the product of 2 quantities equals the product of 2 other quantities, then either pair of values may be used as the means, and the other as the extremes of a proportion. If the product of 2 quantities equals the product of 2 other quantities, then either pair of values may be used as the means, and the other as the extremes in a proportion. Let me show you what this property is talking about. Once you got it copied down. If the product of 2 quantities, 4 times 3, equals the product of 2 other quantities, 2 times 6, then either pair of values may be used as the means, let's just go with these, and the other as the extremes in a proportion. So, for instance, when we go to set up a proportion, as long as the 3 and the 4 are the means, 4 here, 3 here, and the 2 and 6 are the extremes, 2 here, 6 here, is that a true proportion? Yeah. Well, what if we'd said 6, 4, 3, and 2? Well, these are still the means, those are still the extremes, is that a true proportion? Yeah. Well, what if we put the 3 down here and the 4 up there, and maybe the 2 and the 6? Now is it a true proportion? Yeah, of course it is. What if we said, no, mister, I don't want 4 and 3, I want those to be the extremes, and we'll make these the means. Okay, so 4 and 3 have to be the extremes, and 2 and 6 the means. Is that a true proportion? Yeah. The key is, because as long as they stay together, does the product of the means equal the product of the extremes? Yeah, as long as you keep them together. So, let's suppose I told you that 5 times 15 is equal to 3 times 25. Either way, you get 75. At your seats, write a proportion, maybe on scratch paper, maybe back to the class notes or somewhere. If you got scrap paper in the front of your binder, just scrap paper real quick. Write down a proportion that has to be true because 5 times 15 equals 3 times 25. Because it is true that 5 times 15 equals 3 times 25, write a proportion that must be true. All right, let's see. Quentin, tell me your proportion.
is to 25. Is 3 is to 15.
And that is a true proportion, isn't it? They would both reduce to 1/5 or 1 to 5. Audrey, what was your proportion?
Same.
The same exact thing? Anyone have a different proportion than what he wrote? Okay, Chris.
3 over 5 is to 15 over 25.
3 is to 5 is 15 is to 25. That is a true proportion. Good. This is not reducible. That would reduce to 3 to 5. Anyone have a different proportion from either of these two? At your seats, write one that's different from one of those. At your seats, write one that's different from those. Jamie, what did you write?
15 is to 5 as 25 is to 3.
The only problem is, remember the 15 and 5 have to stay together. So if you put the 15 here, it would have to stay with the 5 right there. And then the 3 would have to stay with the 25. Does that make sense? Because either pair is the means or the extreme. So if you're going to say 15 is extreme, 5 also has to be extreme with it, and these both have to be means. Does that make sense? All right, did anyone have this one by any chance? Okay, how many had a different one? Okay, Genesis, what was yours?
5 is to 3 is 25 is to 15.
Outstanding. The 5 and 15 stay together. The 3 and 25 stay together. Do you get the idea? Technically, there are 8 different proportions you could write from any one pair of products, pair of equal products. Okay, so yeah, a lot of different ways we could go with that. Now, before we get to our next property, I need you to flip for just a moment back to the axioms postulates section of your notebook. Axioms postulates section of your notebook. We have another axiom to add that we really haven't needed to worry about till now, so we've waited to give it till now. Axiom 14 says, like powers or like roots of equal quantities. Axiom 14, like powers or like roots of equal quantities are equal. Like powers or like roots of equal quantities are equal. Here's the idea. Let's take a number like, give me a small number here. Kendall.
Any small number?
Any small number.
2.
2. All right. And let's say, what's a number that's equal to 2, class? 2. Very good. It's the only number you could have said. That would have been right. All right. And let's come up with some other small number here. Genesis? 3. Okay, well, let's suppose we raise 2 to the 3rd power, and let's see, what's another power that'd be equal to 3, class? 3. All right, what is 2 cubed? 8. Now watch this. If you cube the 2, guess what you get? 8. They're equal to each other. Mind equals blown, right? Okay? Now, let's suppose, though, Kendall's like, no, Mr. Dasky.
4.9.
5. And Genesis is like, 7. On your calculator, what is 5 to the 7th power? So I ain't doing it in my head. What is it?
78,125.
78,125. Well, guess what? When you raise 5 to the 7th power, you know what you're going to get, class? I do this in my head. 78,125. And notice that are equal. Boom! If you take the same power of the same values, they're going to be equal. Again, duh. That's what makes it an axiom. You could have taken a number like, I don't know, 16, and said an equal number like 16, because that's the only number that's equal to 16. And suppose you're like, let's take the 4th root. And over here, let's take the same root. So let's take the 4th root, because that would be equal to the 4th root. What's the 4th root of 16? 2. 4 is the square root. 4th root is 2. And what's the 4th root of 16? Look at that. You take the same root of the same number, you're going to get the same thing. By the way, that's what makes an answer key possible, right? On my answer key, I take this root of this number, I get this. So if you get the same thing, hey, that means you're right. Okay. Anyway, never thought of it that way before. It's just, axioms are what make answer keys possible. But anyway, duh, right? That's what makes it an axiom. All right, now flip that. Knowing that, property 3. Recognizing that that is true, accepting that that is true, let's talk about property 3. The mean proportional between two values, equals the square root of their product. The mean proportional between two values equals the square root of their product. We've kind of already seen this, haven't we? Right, when we said 8 is to x as x is to 18. And we said, well, that gives me x squared equals 144, and the square root of that is 12, or positive negative 12, right? The mean proportional equals the square root of the product of 8 and 18, right? Because you cross multiply, right? The product of the means equals the product of the extremes. So even if I had something like, e is to x as x is to j, for instance. Well, I know I'm going to multiply e and j, and then I'm going to take the square root of that product. And that's what the mean proportional is going to equal, right? So that technically, do I even need to go to the trouble of cross-multiplying? Not really. I'm just going to multiply and take the square root, right? And we've seen that already. Property 4. It's kind of interesting fact, and then when you see the proof, it's like, oh, duh. The products of the corresponding terms of 2 or more proportions, the products of the corresponding terms of 2 or more proportions are in proportion. The products of the corresponding terms of 2 or more proportions are in proportion. Let's say, for instance, I've got the proportion 1 is to 3 as 2 is to 6, and I've got the proportion 4 is to 7 as 8 is to 14. First of all, are we settled that those are true proportions? Everyone agreed those are both true proportions. Okay, so if you have two proportions, here's what it's saying. If you were to multiply the corresponding terms, then what you get is another true proportion. Boom. Now, why does this work? Well, let's show some letters here so it doesn't hinge on just these. Let's suppose we had A is to B as C is to D. And let's say we had W is to X as Y is to Z. Well, really, if I'm multiplying corresponding terms, I'm really just multiplying A by W, B by X, C by Y, and D by Z, correct? Which is to say I'm multiplying A over B by W over X. And C over D by Y over Z, right? So I'm multiplying two quantities that are equal by two quantities that are equal. If equals are multiplied by equals, the products are equal. Of course it's got to be true, right? But it's to say that if you had two existing proportions, you could form a new proportion by simply multiplying corresponding terms. Make sense? Questions on that?
Can you say number 4?
Yeah, one more time. So if the corresponding terms of two or more proportions, which would be the products of the corresponding terms of two or more proportions, are in proportion. The products of the corresponding terms of two or more proportions are in proportion. Property 5 says this: in a series of equal ratios, meaning I don't just have one ratio equal to 1 in a proportion, but in a series of equal ratios, the sum of the antecedents is to the sum of the consequence, not consequence like consequences, but like consequent with an S at the end. Okay. In a series of equal ratios, the sum of the antecedents is to the sum of the consequence as any antecedent is to its consequent. In a series of equal ratios, the sum of the antecedents is to the sum of the consequence as any antecedent is to its consequent. So let's suppose for a moment we've got some equal ratios. Let's say Q is to A as C is to H as E is to J. Okay, we're going to say all of these ratios are equal, which is a bit of a stretch, but we're going to go there. All right. Well, we know already, right? So what this is saying is that the sum of the antecedents, Q plus C plus E, is to A plus H plus J, the sum of the consequence, as any one of these. Let's go with Q to A. Okay, we'll say that the sum is to the sum as any antecedent is to one. We could have picked C to H, we could have picked E to J. It really doesn't matter. Any of them would be true. Well, think of this. We already know that QH equals AC, correct? Further, we also know that if we were to ignore this for just a minute, we also know that QJ equals AE, correct? And so if we were to take, for instance, equal quantities like QH and QJ and add them together, that would have to equal these two added together, because if equal quantities are added on to equal quantities, the sums are equal. So add QJ to this and add AE to this one, right? We just added equal quantities to equal quantities. We know that's true. Furthermore, we could add another set of equals in there. For instance, we could add, well, for instance, let's just add QA to both of those. Let's add QA to both of those. Well, I'm adding equal quantities, obviously by identity, equal quantities. Well, at this point then, I could factor this out. I could say Q times A plus H plus J. And here I could factor an A and get Q plus C plus E. Couldn't I? I'm just factoring out the A. And I notice that if I have the product of two quantities equal to the product of two other quantities, either pair of values may be used as the means, and the other pair of values as the extremes in a proportion. So it's a little bit more obscure, but here's the idea. Suppose we had some equal ratios, like for instance, 2 to 5 is equal to 4 to 10, is equal to 10 to 25, right? These are all equal ratios. They all would reduce to 2 to 5. Then if I were to take the sum of the antecedents class and the sum of the consequence, oh, that's equal to all of these. I could have also formed a new ratio by just adding these antecedents and consequence and getting
14 over 35.
Hey, that also equals 2 to 5. Or maybe I could have added these two.
12 over 30.
12 to 30. Hey, it doesn't matter which ones you take. If you have equal ratios, you add the antecedents together, you add the consequence together, you're going to get a new ratio that, guess what, is equal to the ones you already started with. So an interesting property there. Again, these are just facts that are true about ratios and proportions. That's why we call them properties of proportions. Questions on these? All right, very quickly, look with me, page 194. Page 194 in your textbooks. Set your notebooks aside for just a moment. Let's very quickly talk through some things together. As we look at number 2 on page 194, it says if R is to S as T is to X and R is to S as T is to Y, prove that X equals Y. Which property proves that X and Y must be equal? Flip back a page. Which property proves that if R is to S as T is to X and R is to S as T is to Y, that X and Y gotta be equal, Chris?
Property 1 corollary 1?
Property 1 corollary 1. I've got 3 terms of one proportion equal to the 3 corresponding terms of another, so of course the 4th remaining terms would have to be equal. Look at number 3. It says if A is to X as A is to Y, prove that X equals Y. If A is to X as A is to Y, prove that X equals Y. Well, in any proportion class, I can always say that the product of the equals the product of the, in other words, cross multiply, right? When I cross multiply Genesis, what do I get?
AY equals AX.
And what can I do with the A's since they're multiplied in both cases, class? By dividing them away, right? Because if equal quantities are divided by equal quantities, the remainders X and Y are equal. So pretty straightforward there. Look at number 4, letter A. They've given you a product that 3 times 16 equals 8 times 6. That's true. Both products equal class,
This one.
which would be 48. There we go. Both of these are equal to 48. There are 8 different proportions you could make. See if you can get all 8 of them at your seats. See if you can get all 8 proportions. And there are all 8 of them. Basically, if you start with the 3 in the first spot, you know the 16 has to be down here, right? So it's just what order you put the 6 and 8 in. If you start with 16, the 3's got to be down. What order do you put the 6 and 8 in? But the 8 there, the 6 has got to be down there. What order do you put the 16 and 3 in? You start with 6 there, the 8's got to be down there. What order do you put the 16 and 3 in? But as long as the 6 and 8 stay together as the means or extremes, as long as 16 and 3 stay together as the other two, it's going to be a true proportion. Did anyone get all 8 of them? Audrey, you did. How many got at least 6 of them? Got at least 6 very different proportions. Good. Homework for this evening. Homework for this evening is to do page 194. Page 194, number 1, A through E. Number 6, A through E. And number 7. Page 194, number 1, A through E. Number 6, A through E. And number 7. Also, study over pages 190 to 193. Study over pages 190 to 193. Yes, ma'am?
What page is it on?
Page 194, number 1A through E, 6A through E, and 7. Study pages 190 to 193. All right, you are dismissed. Have a wonderful rest of your day.